Today we're going to be having 4 case studies. The first one will be presented by Christine Mendenhall. Christine is a structural engineer who has worked with WSP for the past 4 years. Please welcome Christine.
Hi everyone, so my name is Christine Mendenhall. I'm with our Lawrenceville, New Jersey office at WSP, and I'll be presenting on Route 71 over Shark River, the span lock failure, and the subsequent road diet. This bridge is between Avon by the Sea and Belmar in New Jersey. I'd also like to take a moment to thank Gerald from NJDOT, who was supposed to present on this today, but he couldn't make it, so that's why I'm having the opportunity to talk to you guys today. An overview of how this presentation is going to go: we're just going to talk about the project, the bridge's history, and then the span lock failure and the subsequent road diet. So the bridge is located between Avon by the Sea and Belmar, is 110 feet long, the bascule span, that's the open grid deck you can see, 66 feet wide, 3 lanes. It gets a lot of seasonal beach traffic. Its truck traffic is pretty low. There is a much larger highway bridge just off to the left of this picture. But I also wanted to draw your attention to the 2 boats. This is just from Google Maps, but it gets a lot of marine traffic that it has to open for. And you can just see that from the Google Maps photo alone. So it was originally built in 1932, so it's about 90 years old. It's the oldest owned and maintained drawbridge by the NJDOT. It's a double-leaf 4-girder bascule with a manned operating house. There are 9 fixed approach spans, and it is the busiest drawbridge in New Jersey as well, with 5,000 openings in 2021. So oldest and busiest. But in September of 2021, there was a span lock failure. So the span lock connects the 2 leaves together to share live load and to lock them together for vehicles to go over. And you can see on the right picture that the lock bar made contact, impacted the end floor beam instead of going into its receiver socket. And on the left, you can see some of the damage that end floor beam received. And I'll go to the next, which shows it as well. You can see the bending in the web and in the bottom flange here. So this is a pretty big deal. And I would like to mention there was 3 span locks on this bridge, and this was the center span lock. So there was 2 undamaged span locks. But while we were out there, this was independent of the emergency, but we also found very significant corrosion on one of the interior girders. As you can see in the top right photo, the bottom flange is almost disconnected from the girder. It's very difficult to access this area, and that's why it wasn't found previously. But during all of this, there was very in-depth investigation of everything, and they found this. So this was something independent, but we found it at the same time. So the emergency response, NJDOT and WSP crews were on site immediately. The Coast Guard had to be notified. The draw span was deemed safe to operate for marine traffic in a day, which was very important that we be able to open this bridge to marine traffic because they had gone out for the day expecting to be able to come back in the same way they went out. So it was very important. That was the first thing that had to be done. And we were able to determine that it was safe to open and marine traffic can go under. So then we turned to analysis, and we had recently done analysis on this bridge at WSP, so that's helped with our quick turnaround for this. So we turned to the question of, can it be open to vehicular traffic now? Can it be closed, and can it be safely driven over? So we had done a recent load rating analysis using a plate eccentric beam model, a finite element model, and MIDA Civil. You can see a picture of it below. The 2 red lines indicate the 2 remaining existing span locks. There would have been a 3rd, and there was a 3rd in the load rating, but we removed it to modify for those changed boundary conditions to see how the bridge was now behaving. We analyzed this model many times for different lane configurations, all of the live loads, legal loads, emergency vehicles. We ran this a ton. We checked for deflections, the remaining capacity of that damaged end floor beam, which we took some pretty conservative assumptions about what section was lost due to that damage, and how much load it was receiving as well to see if there was any issues there. We also evaluated the remaining fatigue life and the span lock, the 2 remaining outside span locks. We evaluated the loads on those. So after all of this analysis for all of the many models that we ran in the office, we also did some safety interlock testing out in the field, and after that, we were able to open the bridge to traffic with the 2 remaining span locks shortly thereafter. It was less than a week, so that was a very quick turnaround. Yeah, so that was really good that we could open that. So some immediate modifications were made. We added PCL programming to prevent similar malfunctions. The existing 3 travel lanes were left open when we opened up the bridge again. This was during the off-season, so it wasn't seeing a lot of traffic as well. But the load rating indicated adequacy for legal loads, so there was no need to post the bridge. But the fatigue check that we analyzed for indicated that we needed to change something. We needed to get some live load off of that mid-span. So we looked at 3 alternatives. And something that was kind of weighed heavy on all of us about how we should go with this decision is the bridge is planning to be replaced in 10 years or so, about 7 to 10. So that was something that we had to really consider. So we looked at alternative 1, which was no changes, no repairs, and no changes to the traffic pattern. Alternative 2 was a full replacement, so replace that center span lock, that damaged tow floor beam, and basically restore the draw span to its pre-damaged condition. And alternative 3 is what we call the road diet. So that was to eliminate a lane and provide bike paths. It continues the 2-lane configuration from Belmar. So it doesn't, while it removes a lane, there's only 2 lanes on either side of the bridge anyway. And it allows for a dedicated left turn movement and improved signal timing. So with alternative 1, the no changes options, there was a lot of issues that we considered, including the increased deflection and vibration of the span without that center span lock. This was a really big concern for our mechanical and electrical team. They were very worried about the very sensitive equipment that is also pretty old on this bridge, and that we would have outages and the bridge wouldn't open and close as intended, just due to this increased deflection and vibration and difficulty with their machinery. We were also concerned about that center traffic lane directly over that lost center span lock and damaged end tow floor beam. So, and specifically with that, we were concerned if there was ever 3 trucks passing over the bridge simultaneously, which in its previous lane configuration was possible, because when the bridge would open, people would queue up, and sometimes, you would get 3 lanes or 3 lanes of trucks. So we were very concerned about the increased stress on those remaining 2 locks, as well as the damaged end floor beam's capacity and fatigue. And the fatigue is really what drove our decision. The bridge couldn't have remained open for its remaining 10 years. With no changes. So that's why this wasn't a good alternative. Additionally, we were concerned about other structural framing in the draw span as well, specifically that damaged girder that was independent of the emergency. But we also needed to verify the load posting. So we did a very in-depth analysis, but we did it in a week, so we really only focused on what was damaged, what had changed there. So we would need to just go through the entire process again, just dot all the T's, cross all the T's, dot all the I's. But we did do a very in-depth analysis in that first week, so we weren't super concerned about the load posting, I suppose. But alternative 2 was a full repair, which was estimated to cost about $3.5 million. So I really wanted to show this picture for this slide, because you can really just see how out of plane that the end tow floor beam is. So we couldn't reuse the existing span lock because it would no longer go into that receiver socket. We also really couldn't put a new span lock in that location. Like possibly we could have, but most likely not. We would have most likely had to move it, offset it from the center, which would have had issues. We would have needed to add new platforms and access systems. The electrical systems would have needed to change. So that would have been a big effort. Or another option was we could put the center span lock back in its middle condition where it is, but we probably would have had to replace the end floor beam. So that would have been very expensive. And in addition to all of this, a new span lock is a very, very long lead item. It's very custom. The manufacturer would have had to come out. Even before COVID times, this was a long lead item, so now it would have been even longer. The structural steel availability would have been an issue. And with all of these changes, there would have been a need to rebalance the span. And in this bridge in particular, there's minimal to no room in the counterweight to do so. So that would have been a concern. Additionally, for the shore communities, the bridge would have been closed for at least 6 months, and that wouldn't have been a good option for them. And this would have been very extensive repairs on a 90-year-old drawbridge. So the cost benefits of it really, they just didn't make sense since it's planning to be replaced so soon. So then we turn to alternative 3, which we call the road diet. So this was actually a very simple and pretty elegant solution proposed by the NJDOT's PM. It reduces the roadway to 1 lane in each direction, which significantly alleviates the live load off of that middle portion. And it shifts the lanes more towards the outside, towards the 2 remaining span locks, which creates similar live load on those span locks as before, because before there was 3 lanes, 3 locks, now there's 2 lanes, 2 locks. Additionally, those 2 remaining locks were designed for about maybe a lane and a half. Originally there was 4 lanes on this bridge, so we weren't super concerned about the remaining locks' ability to carry these 2 lanes without that center lock now that they were shifted, and there was one less lane. So all of this resulted in a longer service life, which will allow the bridge to continue operation until it is fully replaced. In addition to this, we added dedicated bike lanes across the draw span and approaches, which is great for a shore community. There's a lot of biking. The center span lock would not need to be replaced to allow it to remain in service, which was a big benefit to this option. As well as the structural steel repairs would not be extensive. It would just be that damaged girder, which was independent of the emergency anyway. So this was the most economical and timely alternative. It had minimal impacts to the local traffic with short-term 1-lane closures that they could do at night, that kind of thing. Nothing too dramatic. And the cost was max $150,000. There's still, the FRP plates haven't been installed yet. They're scheduled to be installed, I think not next week, but the following week. So the cost isn't finalized yet, but they're not expecting it to be anywhere near the cost of alternative 2. So all of this, keeping in mind this all happened in a week to try to figure out what to do. The coordination was a pretty big part of this. Belmar readily accepted this alternative. They were very happy with it right off the gate. Or Avon by the Sea took a lot more convincing. They were very concerned about that loss of that lane, and ultimately there was a meeting with the mayor, and the plan was ultimately accepted. What really kind of convinced him is he's a very avid biker. He was very excited about the idea of the new bike paths, and he said he would try to be one of the first people out there once the FRP plates are installed. So yeah, it was a very productive meeting. Additionally, there was very significant internal coordination at NJDOT between all the different groups: maintenance and operation, structures, traffic. Directors were involved, assistant commissioners were involved. So it was a very big coordination effort for this. But all eventually agreed that the road diet was the path forward for this bridge. The road diet made a lot of enhancements. So it extended the bike lanes to connect Avon and Belmar. It added 4 parallel parking spots, great benefit for a shore community. And it just continued the 2-lane configuration that was already on either approach of the bridge. It created a dedicated left turn lane with an 8-vehicle queuing capacity with protected and permitted left turn arrow added, and it eliminated a risky merge in Belmar. So before there was 3 lanes, and when the bridge would open, everybody was trying to jockey for position so that way they could get, over the bridge faster when it did close. But we don't have data to back it up. It's more of an observation at this point, but we're seeing Avon by the Sea clear out in about 2 to 3 minutes with a lot less jockeying. It's a lot less risky. So even though we did lose a lane, we feel that the traffic patterns have improved with that dedicated left turn lane because it's a lot less risky. There's a lot less jockeying around. But we also added new guide signs directing Belmar-bound traffic to remain on the parallel Route 35, as well as installed high visibility crosswalks at 18 intersections as part of a safety improvement. So there was a lot of benefits to this project. I wanted to specifically talk about the FRP bike path as well. Like I said, it hasn't been installed yet, so I don't have any pictures to show, but I'm showing a similar bridge in Chicago so you can get an idea of what it'll look like. So it's a fiber reinforced composite system, and we chose it because it's lightweight and it would not affect the leaf balance significantly. That was a big issue on this bridge because of the lack of room in the counterweight. And it is the first of its kind in New Jersey, so that was very exciting. So we installed it directly over the existing open grid deck. We removed the anti-skid studs so that way it could lay flush and those wouldn't be poking in, and then we just kind of bolted it down. So it was a pretty it'll be a pretty easy installation. Additionally, we repaired those girders where it was severely deteriorated. You can kind of see the fresher paint in this photo. Part of this is we added quite a bit of weight to this bridge. We added the weight for this these girder repairs, and we added the weight from the FRP plates. So we kind of looked at, well, how can we balance the span again without significant issues? And there was, the photo on the right shows that there was some balancing blocks at the toe, which we were able to remove some of those, and they were on both leaves, so that was great for us, and that was able to compensate for the repairs, so we didn't have to really touch the counterweight, which didn't have room anyway, so that was a great benefit. And the leaf balance was verified without adding to that counterweight, and there was less than 100 pounds difference at the toe, so that was deemed to be an acceptable option. And the span operation was verified as well. So in addition to this, a lot of traffic signs were added. There was enhanced signage and lane controls at Route 71, Fifth Avenue intersection. There was signs added, things like raise your plow so they don't damage our new FRP plates, and temporarily people are asked to walk their bikes. Apparently they are not. They're very excited about their new bike path, but soon they'll have their FRP plates, so it'll be a little bit safer. Before and after the road diet. So I have the before on the left and the after on the right. You can see that striped median in the middle to get the load away from that lost center span lock in the middle. And you can see the striping for our new bike path. Just kind of in the background of this picture, that's where the bascule span is, so that the striping does continue at this time, but the plates will be installed soon. And then we have our safety improvements at intersections nearby. I think this is something that the mayor of Avon-by-the-Sea also kind of requested, so that was another benefit to our meeting, as we could accommodate some of these things and make him happier about the changes. Do you guys have any questions? And thanks for your time. There was a malfunction. I don't know too much more, just a malfunction. It's very old machinery, so maybe that contributed. Go ahead.
You know who makes that effort?
We got it from Strongwell. Okay, thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.